Right, I think you all can see my screen. Can you see my screen?
Yes, sir.
All right. Right. Himesh, what about this hexadecimal? Have you done this hexadecimal numbers and all? Are you aware
Yes.
of? Are you aware of that?
Yes, sir.
All right. Okay, so we start from this number system, right? Right. All right. So, what do you mean by hexadecimal number system? So, why we use this number system? What kind of a values in a computer we are representing this? Can you tell me, anyone? What is the use of this number system? Right? What kind of a usage having in a computer? We all know that hexadecimal number system, right? So, but you should know what is the usage of it. Anyone? Hexadecimal number system. Where we use this number system in a computer? No point of knowing without that, right? You should know where these number system use. Where? Samiha, any idea? Right.
Sir,
Yeah.
sir, like it is like used to represent colors.
Yeah. Represent colors. Good point. Yeah. Colors. RGB colors, right? Right. RGB color combinations. They use this kind of a number system, 16 digits number system. Hexadecimal number system we call as 16-digit number system, right? We not only colors, right? Our lot of numbers in a computer, for example, MAC address, media access control, or we can say physical address, right? Physical address, right? Remember every computer, even your laptop, even your desktop, laptop, desktop, right? Laptop, desktop, whatever the smartphone, right? Whatever network enable devices, right? Network enable devices, we are having this address called MAC address, media access control address, which is represented by 16-digit number system, or which is represented by hexadecimal number system or hexadecimal number system, right? So this media access control address, right, represented by this 16 digits, right? So this is the main usage of this number system in a computer, right? Whatever the networking enabled devices, even you know, at the moment you will get network printers, right? Network printers, the printer coming with the network port, that is called network printer. So this network port having this MAC address, media access control, right? That address is represented by this number system, right? Even your smartphone, let's say Apple, if you have Apple phone, definitely that Apple phone has a Wi-Fi card, the wireless card. In that wireless card, you will get a MAC address. That MAC address is denoted by this 16-digit hexadecimal number system. Okay, so that is the usage of it. Samiha, did you get it?
Yes, sir.
Very good, right? That is the hexadecimal number system. Because before I am jump into the hexadecimal number system, I just give the overview of the hexadecimal number system, why we use, where we use, right? And I will show you now where in my I have, this is my laptop. No, you also need to do this, right? Click on Windows, type cmd, go to command prompt. This is called command prompt, right? Right, actually I would like to do the session with the most of the demonstration, because this is not a, this is a subject of computer science, so whatever the things, if I can elaborate, I will use it, right? So this is called command prompt, right? This is called command prompt. This command prompt, what is happening, right? What is this? This is called a kind of a user interface. Earlier user interface is like this, right? You have a you have a black screen with a blinking cursor, right? That is called this, right? Black screen with a blinking cursor. This is called the command line interface. Command line interface. Did you open this, everybody? Himesh, Samiha?
Yes,
Yes,
sir.
sir.
Very good. Okay, now I am going to type small command. You can type with me, right? Command would be IP I character I P CONFIG IP config space / all. Just type that. I will show you again the command, this one, right? This is what I am going to do is I am going to show you this hexadecimal number system where it used by in a computer. That's what I am doing, right? Nothing but I'm not doing any practical things, but I want to show you where these numbers are there in the computer, in your own computer. See, IP config. I will tell you this meaning as well. IP config space / all. Everybody got this? I think some details you must get it. Did you? First time it
Yes,
might
sir.
it might be wrong. Second time try it. Command is IP CONFIG. It should be together, right? Space, there's a space. Okay, then / sorry, / this one, right? And then all. Samia, did you get this?
I got it wrong now.
Okay, just type again command. If you got it wrong, it's a unrecognized bad command or something, some error message, right? If you correctly got it, you will end up with this kind of a value, some details about Windows IP configurations. Just try it. Sometime it might if some mistakes they are in your command, it will not run properly.
I got it. I got it correct now.
Okay, great. Right. So this I will tell you this is the basic command. Remember when I already telling to my students, when you learn that this is the technology subject, this is not only the book stuff, right? You should know the basic computer things, because you definitely you are using a laptop or desktop nowadays, right? So you should know why we these command, very simple. These are very basic commands I am teaching you, right? You should know, right? This is kind of a practicals, right? But this is related to what I I am smart enough to map these things to your syllabus as well, right? Right here, IP configuration means it's like IP config means it's meaning of IP configuration, right? IP config. This is not a big thing, right? Very simple thing. I will make it simple. IP means internet protocol, right? Internet protocol, right? IP means internet protocol. What do you mean by the IP? You know, every computer, every network enabled devices, if you want to access the internet, you should have this kind of a IP address, right? IP, the stand for internet protocol, right? It's a kind of a, assuming that it's a kind of a your home address, right? Everybody, let's say you are living in Moratua. When you living in Moratua in some place, right, you will have some street name, and then you will be then your home, where's your home, there will be a specific address on that. So that address define that, okay, this home is, right, very unique with other homes because it has a unique number, because your address can't be duplicate with your neighbor address. It should be totally even slightly there should be a one different, right? For example, 25 upon 1 and 25 upon 2, 25 upon 1 and 25 upon 2, these are two addresses. Sometimes this is your address, this is your neighbor address. Yeah, but two different address, but you can identify from this address, right? Everybody can identify where you are and where this person house. So same thing here, when you are accessing the internet, how do you identify? The internet is identified by this address. Got it? I think you got it, right? So this is called internet protocol address. Okay, right? Great. So that is the logical address. We say that logical address. It's not a physical address, it's a logical address. That means the system define a unique address to your computer while you are accessing the internet. Got it? That is called IP address, right? Every computer, every device, even the tabs notebook, whatever the device, it takes the address, because this is belongs to your syllabus as well, right? Don't think that this is out of syllabus. This is your syllabus, what I am teaching you. Now I am coming to what I want to show you. See, this is called physical address. Oh, what do you mean by physical address? Okay, let's finish this IP address. I will show you my IP address, because now I am connecting to my yeah, I have SLT fiber connection in my home, because my all the classes would be accessing from that connecting to the internet through this my Wi-Fi router. This is where's my address. Wait, yeah, here. This is my IP address, right? IPv4. IP means internet protocol, right? Internet protocol, right? V4 means version 4. V means version 4. My address would be what? 192.168.1.6. This is my unique address, because this my laptop is connected to Wi-Fi. See, I will show you. See, SLT fiber. I am connected to my SLT fiber now. So from the XLT fiber means actually I am using the router. My laptop is connected to my Wi-Fi router. It is SLT fiber. So from the router, they have given the IP address or the unique address which is assigned to my laptop. Okay, now you are accessing the internet. Okay, then let me give the IP address to you. It assign 192.168.1.6. This is the address. See, I have many devices at home. I think my children use, tabs, mobile phone, and my other friend, my cousins use some devices, right? So anyway, we have more than 10 devices, which is network enabled devices. So they have each, and so this is my laptop IP address. This will never duplicate with some other device because this is unique. My other devices having 192.168.1.4. This should be 192.168.1.5. So this is a unique from my address. But right, when we say I have a tab, so my tab is accessing internet from this address. I have a smartphone. From that, my smartphone is going internet from this address. So unique address. Got it? I think everybody clear this.
Yes, sir.
Yes.
Very good. Right. This is the okay. So now I am coming to the point where what do you mean by this is a logical address? See, but this is not a, this is actually this is the decimal, right? 192.168.1.6. It's a decimal number, right? It's a decimal number system. It's a decimal number system because 192 is a decimal number system. 168 is a decimal number system. But we are searching the hexadecimal. Where's the hexadecimal? Here you will see this is hexadecimal number system, which is assigned to, it's called the physical address. Okay, now I will come to the point. What is this physical address? Physical address means, right, I earlier said whatever the network enabled devices, you should have a network card, right, or the wireless card, right? I will show you from the internet, then you will get a proper idea, right? What is this network card or wireless card? I will Google, right? I will show you. We say wireless card. We say network card, NIC card. Normally, this is coming from the laptops. Sorry, desktop, right? This NIC. This is called network interface card. Our network cable, we say network cable or the patch leads are, connected to, see, like this. This is how the internet it's connected. Actually, this is the network interface card, right? We say that LAN adapter, right? There are different names, but refer to the. So why we use it's to accessing the internet, right? Even the right, that is called network interface card. So this is a LAN card, normally desktop lap. We say I will show you laptop NIC, laptop NIC card. When it's come to the laptop, it will simplify. See, this is called laptop. Normally, this is wireless chip, right? Wireless chip also having, right? Wireless chip also having, see, now you will get this one. See, MAC ID 6C71D91, right? This is called hexadecimal number system. This number belongs to hexadecimal number system. This is wireless card. Every laptop we have a wireless, otherwise we can't connect to the internet. So when it's come to the, you can see this photo, right? Right here, See, this is the wireless interface card, right? This one, right? So every laptop we have this kind of a card, right? Right? This kind of a card we have it. See, this is also why. See, WLAN. What do you mean by WLAN? Here it's a WLAN. WLAN means wireless local area network. It's a MAC ID. See, this is called hexadecimal. So this is a unique ID. Remember, unique ID. MAC ID is a unique ID. Why we are saying the unique ID? Because it should be recognized by the each and every, one particular card from the rest of the card, right? So that is called the physical address, right? That means every network interface card having the physical address or the MAC address, this MAC address is denoted by hexadecimal number system. This hexadecimal number system is unique with other network card interface. When you transfer the data, bits and bytes in a data communication, when you transfer the bits and bytes, actually you are transferring bits and bytes into this network interface card from the internet. From the internet, it writing on this network interface card. Why this physical address? Because the internet is actually recognize your computer from this physical address, internet. But when it's come to the laptop, then your network, when it's come to the your network, it will recognize by the IP address. That's the difference between the physical address and the IP address. So when it's come to the IP address, it's identified within your local area network or within your home network. Other than that, when it's come to the internet, how the internet should identify your computer by using this physical address, which is burn-in address, right, in your network interface card. Got it? So that physical address is denoted by, right, this hexadecimal number system, right? Am I clear to you? All right.
Yes, sir.
Yes.
Great. Right. Now we'll come to the lessons again, because that is the kind of a demonstration where you should understand why we learn these things, where are we these, right, in our computers. Right. Now we'll come to the topic. The hexadecimal system is very closely related to the binary system. Hexadecimal sometimes refers to as a hex. Okay. It's a base 16. Base 16. Right. And therefore need the 16 different values to represent each digit. Right. Because it is system based on the different digits, it starts from 0 to 9 and letter A to F. It's like this. Right. It's hexadecimal numbers are coming like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As of now, the digit would be 0 to 9. Then we have it normally actually we have 0 to 10, right? 15, but we are not saying that, right? But here in a technically we call 10, the value 10 would be A, value 11 would be B, value 12 would be C, 13 would be D, 14 would be E, 15 would be F, right? That's how values comes. Actually you can write 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you can say A, B, C, D, E, F. A refers to value is 10, B 11, C 12, D 30, E 40, and F 50. That's how the digit comes. Digits and characters. This is A to F, 0 to 9. This range is called hexadecimal number system. Hexadecimal number system, right? Right. I think you are clear on these things, right? Right. Now, what they say using the same, so right. So we will directly get the value, and we will do some example. Then you can understand easily, right? Okay. Himesh, what do you mean by the denary? Denary means what? Denary value means what?
Sir, base 10.
Yes, base 10, right? It's a base 10 value. That is called, actually, you can say it's a decimal number system. Very simple to say decimal number system, but in your syllabus, it says denary. Right? In your syllabus, they don't talk about called decimal, they talk about denary. So denary refers to the decimal number system. That means 0 to 9. That's it. Right? We don't have any value on that. That is 0 to 9. Right. Now see how they represent hexadecimal number system. Normally, because you know the maximum value 0 to 15, no? That means how many digits? 16 digit. 16 digit number system, when you go to the when you represent by the binary, you can go maximum, you have to go minimum, you have to go to the 4 characters, 4 digits. That means we say this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, right? Normally we say 2 to the power 0, 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. When you multiply, you will get 15 number system, 15, 0 to 15, right? That's how it comes. Normally it's like this. We get a number system like this. We say binary 1, 1, 1, 1. We say binary. This is binary, right? So if you get, we know that base 2, 2 to the power 0, 1, 2, 3, no? We know that 8 plus 4 plus 2 plus 1. The value is here 15, right? 15 base. What is the base of this? Samia, what is the base of this? I said that. What is the base?
10.
10. Yes, base is 10. Here base is 2. Binary base is 2. Denary base is 10. Then how you represent this 15 into hexadecimal? What is the number? What's the digit? 15. How do you refer it?
Letter F.
Yes, letter F. Very good. Letter F. Because you know, we say that 0 to 9, then 10, 11, 12, 13, 14, and 15. We say 10 means letter A, 11 means letter B, 12 means letter C, 13 means letter D, 14 means letter E, and 15 means letter F. That means 15 denary number reference to the hexadecimal F, base is 10. Remember, with except the denary number system, everywhere you have to put the base. We have a base 2, like you have to put a base. If you are representing hexadecimal, we say CF. This is also hexadecimal value. You have to put the base 10, 16. Right? That's the idea. How this 15 come? 15 comes like this. F is 16.0. 16, every power of 0 is 1. Right? Now F is actually 15. You have to multiply 15. 1 into 15, 15. That's how 15 comes. It's not come automatically. When you calculate it, we say C. How this value come? C. This is 16.0 because only a one value. 16.0 is a 1. C means what? We know what's the value of C number. The higher 10, 11, 12. What's the value? 12. Then 1 into 12. Right? This 16. See, this C is represent C16. The base 16 of C hexadecimal number system represented by the denary number 12. Got it? මේ එන එක තේරෙනව නේද?
Yes, sir.
Okay. Take it D. D is 16.0. 1 into D means 13. 13. Base 10. D means denary base 13. That's how it comes. Right? Okay, now I am taking another value. We'll say, where's this book? Yeah, so that's how it here mentioned. Himesh, are you okay with these things?
Yes, sir.
Okay. Okay, now we will do some conversions. Converting binary to hexadecimal values. So we get the same examples, right? 1 0 1 1 1 1 1 0 0 0 0 1. Right? Give me 1 second. Right. Here now how we do this? What they say, first split into up to groups of 4 bits. Remember, so how do you, when you are splitting these binary numbers, right, you have to start from right to left. Don't start from here, left to right. No, you have to start from right to left. That means you have to split like 4 numbers. Here 1, right, like, okay, now you have 4 numbers. right? Okay, now yeah, you do some calculations. You know this 001 here, how this comes, right? What's the value here? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Here 1 is 1, remaining 1. Here we have 1, 1, 1, 0. Here 0, 1, 2, 3. That means here 8, here 4, here 2, here 0. What's the value? 12, 14.
14.
14 represented by hexadecimal. What's the value? Yes, E. From here it's come E. Here 1, here E. Then next one here 1, 0, 1, 1. Right? One, 0, 1, 1. Here 8, 3. Right? You know this now. I'm doing straight away. 11. 11 means AB, because 11 represented by hexadecimal number B. This is B. Very simple, right? B, E, 1, 16. It should be 16 here, base. Himesh, got it? Did you get this? Make
Yes, sir.
Okay, great. Okay. Right. Okay. Can you other than that, I will give only 2. Others are homework, right? Here, can you split and give me the answer now? This one, and this one. J, I last. These are homework. We don't do all this because we don't have time. But at the moment, you have to do this and I give me the value. I give only 5 minutes, right? Very simple. Huh? Now do it. Now 7:38. I will finish it 7:43. Yes. All right. I need a hexadecimal value. Finish?
Yes, I'm finished.
Okay. Himesh, finish?
Yes, sir.
Okay, what's the first one answer? Himesh, Samia, first one? I?
I got FF7D.
FF?
7D.
D. Right. For the second one?
I got 167AE.
1, 6, 7,
AE.
A. Am I right? This one? Am I right? This one, right?
Yes.
Okay. Himesh, did you get same thing or different?
Yeah, sir. I got the same thing.
For both?
Yeah, sir.
Okay, great. Right, then we'll check, right? Check from here straight away. What is the first one? Correct?
Yes, sir.
Right.
Sir, I got D for the last.
Sir,
This one?
it's FF7D, sir.
Yes, sir.
This one?
No, sir. Yeah, sir. That one.
The I1. Yeah.
D. Yeah, wait. I think I wrote wrongly. Here we say 8, 4, 1. 8 for 13, 12, 13, no, right? 13 means 10, 11, 12, 13. Yes, D. It should be not C. I put C. Yes, that's correct. Here, this one, this one, this one. Here, 8, 4, 12, 12, 14. 14 is E. Correct?
Yes.
This one, 8 to 10. A. This one, 7. And this one, 6. Haridha, 6, 7, 8. This one?
Yes, sir.
Okay, right. I think you can do these things later, right? Right. Okay, this is other way around, right? Right, other way around is very simple, right? We say I will take one, C3, C would be we know C is A, B, C. A, B, C. That means 13. 13 you represent 8, 12, 13, right? 6 means you can straight away put like this. Then you will get 0, 1, 1, 0, 1, 1, 0, 1. This is base 2, right? Likewise, can you do this, only these two? Give me the output. I will give only 2 or 3 minutes. These are homework, right? Homework. Now you have to do these things. You can do these things. You can see, right? I straight away put the values. That's it, right? Very simple. Finish?
Yes.
Okay. What are the answers?
Sir, 1011.
From left to right or right to left?
Sir, from left to right, sir.
Left to right. Okay. 1.
No, sir. Sir, left to right is
Left to right. Yeah.
1011.
1, 0, 1, 1.
Sir, 1010. Sir, 0110.
Right. 0, 1, 1 here. Here 6. Here we have 8 to 10. 10 means we have A. Here we have 8, 3. That means 11. We have B. Correct. Sami, I think you also get same value, right?
Yes, sir.
Okay. Sami, what's the output of this?
from left to right.
Okay.
I got 1001,
Okay.
1100, and 1100.
Right here, 1100 is 8. 8 for this 12. 12 means we get A, B, C. That is C. Here also C. Here 8 plus 1, 9. Yes, correct. Good. Very simple, right? All right. Okay, now this is kind of not like easy, but it's also easy. But we should know denary to hexadecimal and vice versa. We already done these things, right? No, not we didn't do this. I just give this example 45A, right? So this is from hexadecimal. Now they are asking denary. So we know that these are the values. Normally hexadecimal, you just to know only up to 4 values. I will get one example. Up to 4 values, we say 1, 4, 5A. Here we have 16 to the power of 16, 0 power. Here 1, here power of 2, here power of 3. Normally every 0, 16 into power of 0 means we know 1, right? 16 power 2 means we have 16 into 16. That is sorry, here 61. I make a mistake. 16 into power of 1 is 16. 16 into power of 2 is 16 into 16. This is 256, right? And here we have 16 into power of 3. That means 16 into 16 into 16. This is 4096. So these are the maximum values you should know in your level. That means, for example, I will just get like this. You should know only these 4 values: 16 into 0, 16 into 1, 16 into 2, 16 into 3, right? 16 into 0 is 1, 16 into 1 is 16, 16 into 2 to the power of 2 is 256, and this is 16 into 16 into 16. That means 4096. These values you should remember, right? That's it. You can do any kind of a calculation, right? Now we'll come to 45A. We know this is 0, this is 1, this is 2, right? We know here 0 is 1. 1 into A means we know A refers to 10. We have to multiply 10 plus here 5. 16 into, we know 16 into power of 1 is 16, multiply 5, right? Plus here we know 16 into 16, how much? It's 256. 256 into 4, right? We say here 1024. Here we have 80. Here we have 10. Here 90. 1024, 90. Right? This is the denary value. Got it?
Yes, sir.
Okay, great.
Yes.
Can you do these two only? Give me the answer. These are homework, right? Hello, finish. Can I have the answers? Samia, first one, what's the answer?
I got 256.
2,
2560.
2560. Am I right?
Yes.
Okay. What about here?
Sorry, sir. 2561, sir, for the F1.
How about second, last one?
Last one, 2996.
2, 9.
96.
Okay. Himesh, did you get these values or different values?
Same values.
Okay, great. A01. This is 1. This is 0. This is this 256 into 10. 2560 plus 1. 2561. Correct. Right, and this one. This 4. 11. 16. Right. This 21. Sorry. BB4. Here 4. Here we have 16 into 11, right? Am I right here?
Yes, sir.
Right. 171, right? Here this one. And here we have 256 into 11.
So it's 176, sir.
This one.
Yes.
Right. Here we have 2560, 256. Right. So correct? Is this the value?
Yes, sir.
Okay, right. Okay, now this other way around, that means we are dividing, right? So we have to, we know that this also we have to divide by 16, right? Here. So they started from this 2004, right? So what they do is you have to divide by 16, right? So this is, we have to do some workings, right? So because this kind of a without workings you can't get straight away, right? So you have to do workings here. We say here remaining you have to do so 16 into 125, right? Maximum, right? Then we have to remain is 4. Then for the 125, how many? 16. We have to get that 6, right? And we have to get the remainder. Here it says 13. Here again, no need, right? You can straight away put 7 is remainder. Then you have to start from this to this, right? From top to bottom to top. You have to write 7. Here 13 means hexadecimal, normal denary D, and 4, right? So this is how the conversion happened from the denary to hexadecimal, right? What is the simplest way to get this? Any shortcut? I think this, because you know hexadecimal number, this you can get like this, you know, how many numbers you should have to represent one hexadecimal number to the binary maximum. Now remember, this is what these values are. What these values are? These values are what? Denary values. Denary values. Okay, right. I am asking not that. I am asking to represent the one hexadecimal value, right? How many binary number you should represent? How many binary digits you should need to represent one hexadecimal number? Samia?
So,
What? I can't hear you.
4 now.
4, yes, 4 digits. Himesh, did you understand what I asked?
Yes, sir.
Yeah, I asked, we say now we have numbers, no, hexadecimal 1, 2, 1 to 9. Now we have A to F, no? These are hexadecimal, no? To represent the whatever the one particular hexadecimal number, how many digits we have to use for with binary? 4, right? Got it?
Yes.
Like this, right? Like this we have to represent, no? So minimum you have to get a 4 numbers, or exactly having, you should have 4 binary numbers, 4 binary numbers to represent the one particular hexadecimal digit. That means one hexadecimal digit represented by 4 binary numbers or 4 binary digits. That's it. Okay. So what if we can convert this straight away to the binary, right? From that binary values we can, you know, form right to left, we take we group 4 4 4 and straight away get the hexadecimal value. Is that easy other than this kind of a division? What do you think? What is the easiest way?
The second method is easier than the division.
Yeah, so what I told you is the easiest, right? Are you agree with Hema? Himesh?
Yes, sir.
Yeah, it's like this, no? I will tell you. So here we have 98, no? Right, we have 98. So what I am doing, I straight away, right, divide this into 98. So better, 98 we can divide by 2 very easily, no? No. දැන් මම මෙහෙම බෙදන්න ඕනෙත් නෑ. දැන් මම දන්නවා නම් if I am good at binary numbers, I know these values, no? I have in mind, no? We know here 2 to the power 0, 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. I know straight away these values, no? Here 1, 2, 4, 8, 16, 32, 64, 1 to 8. I have in mind, right? So I know this level. I think you also know these values, 2 to the power values. So if you say straight away 98, how can I write straight away to the binary? I can write 98, no? 98, then 1 to 8, we can't get it. It's more than that. Then 64, yes, I can put 64. Then 64 into 64, after that we have a 32. We know 64, 32, it's a 96, yes. It's below, no? So I can put 1 here. Okay, now another 2 is remaining. 96, no? Then 32, now we start from 64. Then here 34, then 16 no need. 16 no need. Then what? 8. 8 also no need. Then 4. 4 also no need. Now 2. 2 I think I need, because here 96 is 2 is 98. I don't need 1. I straight away get this one. I don't know, but sometime you might get this one straight away, because I have in mind, I know this straight away. 1, 2, 4, 8, 16, 32, 64, 1 to 8. I have in mind. And I know this 2 to the power 0. I know this 2 to the power 1. I know this 2 to the power 2. I am well aware of this. Right? So if I get 98, I know what is the maximum value I get. I can't get this value because it's more than that. Then 64 definitely I can get. That's what I pick this. 32 I can get. 64 into 32, it's 96. Okay, now I have only 2. Got it? Got it? Make a
Sir, can
තේරුණාද
you
මේ?
explain that again?
Okay, I'll explain it again. It's like this, right? Now you have this value. I think Samia, you are aware of this, right? 1, 2, 4, 8, 16, 32,
Yes,
64. So without this, you can't, make this shortcut, right? This is, you are aware, right? I don't want to show, I don't want to tell you, you know this one, right? You know, this is 2 to the power 0. You know 2 to the power 1. Here 2 to the power 2. Here 2 to the power 3. You know 2 to the power 3. So 4. And you know about here 2 to the power 6. Here 2 to the power 6. Here 2 to the power 7. These are well aware. Now you have to check whether now I have to get this 96, 98. Now 9 to get this 98. What is the maximum value you have to get? If you get this 128, you can't get it because it's more than 128. You have to first select the point where you have to start, right? 64, it's okay. 64 is below 98. Okay, I will get this one. That means I will. Right. Here, right. So 64, I get it. I got it. Now I have to got. Now we have to match this value. Now I have 64. No. So up to 64. Now starting from 64 till 98, I have to add values. Now I put 32. Then I am checking, okay, 32, how without I can put 32 because 32 plus 64 is 96. Okay, another 2 is remaining. We can't get 16 because it will more than that. I can't get 8, only 2 I need. I will get that 2 from here. Now my value is 1 1 0 0 0 1 0. Got it? Terunada, did you understand?
Yes, sir.
Okay. Himesh, did you get this point?
Yes, sir.
Good. Right. Now, then what I can do, we know if you are get the binary number, very straight away you have to, right to left, you have to, make group of 4 digits and, make it like this. Then here we know hexadecimal. This is, what's the value here? Here 2. What's the value here? Where 4, sorry, 2 4 6, right? Hexadecimal value, this would be 6 to 60. Got it? Am I right?
Yes.
Right. Right. Then if you have, see, this is now 227. So 227, you should know this now. Now you have to add another power to the normal way. That means 1 2 4 8 16 32 64 128 128. Then you have 256. Or if you have here this one, big one, 512 1024, then 2048, then 900, this one, right? Like this, 800, 192, I think, like this. I don't know this level, you don't want to go, right? See a decimal numbers, no? Check the maximum value there. Your book says it go 5,000. 5,000 means, yeah, here 5,000. Better to, at least you should know this level, what I wrote now. Remember this, right? This is very easiest way, right? This one. So you should know this is 2 to the power 1, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Here 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, 2 to the power 10, 2 to the power 11, 2 to the power 12, 2 to the power 30. Right? You should know this value 1, 2, 4, 8 multiply 2 into 2 into 2. Very simple. 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 800, 192. I think this should be correct, no? Yes, 800, 192. That's correct. So you should, if you are well aware of this, you can do anything, right? Here we have this one, 227. We say this one. 1000, no? I know 1024. 1024 is 2 to the power 10. 2 to the power 9 is, I know 512. 2 to the power 8 means I know 256. 2 to the power 7 means I know 128. So now 1000, no? 2 to the power 10 means 1024. I can't get to this. I can't start from, get the binary value from here because it's more than 1000. So I have to start from here. Now then you have, because you have to, you should know where your starting point. This is 2 to the power 9. Then we put 1. That means you are adding 2 to 512 already. Then 256. 512, 256. What's the value? 8, 6, 7. 768. Right? Then 768 again. You have to check 128. Yes, you can add 128 here. 128. 6, 9, 8. 896 you have now. But remain, you have still, you didn't get this one. Here 2 to the power 7, 2 to the power 6, 64. Right? I think you can add 64 here. No worries. 64. 0, 6, 9, 960. Right? Again 2 to the power 5, 32. Yes, you can add that also. Right? 960, 32. 2, 9, 9. Right? That also possible. Now how? 2 to the power 9, 8, 7, 6, 5. Now 2 to the power 4 is 16. 16 you can't add because you only need 8. After 16 you will get 8. Okay. Then 8, 4 is 0, 2 is 0, 1 is 0. Okay. This is binary value of this. Right? This is the binary value of 1000. Then move straight away, right to left, you divide in group 4 to make it hexadecimal. Here, here what? 8, no? Here, what's the value? 1, 2, 4, 8.
8.
Here, 2, 4, 8. 12, 13. Sorry, 12, 14. 14 means E.
E.
Here,
1.
1, 2, 3. 3 E 8. 60. Got it?
Yes.
I think this is the simple way when it's come to the denary numbers to hexadecimal. If you are going to divide, right? But remember, I don't know but scientific calculator, are they allowed? Not sure. But if they are allowed scientific calculator, division is simpler than this. But I don't think they allow scientific calculator, right? So this is the simplest way when it's come to do this. Okay. So can you do these two with the simplest way? Give me the values. Finish?
No, sir.
Okay. Himesh, did you doing
So
finish? Ah, okay. So don't divide and get it right. You try to figure out what I taught, right? But you should know the whatever the values. I remember that this like this these should be in your mind. Without these things, you can't get the shortcut. If you want to get the binary value of 3743, so you can't get this one. 4096 is more than that. So then you have to start from here. You have to start from here. You have to put one, and then from 2080 to 2086 48 till 3743, you have to add the values and get the binary and make it 4 digits from right to left. That's it. I think that's the easiest way. I don't think other way is easiest. But if you are good in dividing, you can straight away divide and get the remainder. But I don't think it's very difficult, no? E9F here.
Yes, sir.
Okay, good. What about this one? 4007?
Sir, I'm still doing that one.
Ah, okay. No worries. You can do it.
So I got FA7 for that. For the
FA7.
FA7.
Right. Correct. Okay, Imesh, got it? I think Imesh, you got right.
Yes, sir.
Okay, great. So you can do the other things as homework, right?
Okay, sir.
Right. This is I will will finish from this. Wait. Here, this one. Use of the hexadecimal system, right? This section reviews the 5 uses of hexadecimal system. This information in this chapter gives the reader sufficient, right? So first one is memory dump, right? I will tell you this is very important. Memory dump. This is not important. Not only this is not for the important for the exam, right? But to your IT knowledge. So in a day-to-day life, sometime when you are when you are using your laptop or desktop, suddenly there are a lot of problem, hardware malfunctions happen, right? Hardware malfunctions. Malfunction means hardware won't work properly as we think. Yes, you remember the computer is like a like a human body, right? Straight, computer, we say brand new computer. So brand new computer you are taking, we say last week you have, purchased a brand new computer, you are working, suddenly that might, having some problem. It's, like for example, for the human, heart attack happen straight away, right? Don't know. So it's a human nature. So remember, the computers also the same thing, right? Because I have been working now more than 15 years. So I am not, actually I am not a I am not a, school teacher or some, because we were I am, beyond that, because I we do, a lot of, at the moment I have IT company, right? I have I just let me know, because you should know to whom, who is your teacher, right? This is my company. This is not a show off thing, right? But you should know, right? So what I am doing, and right, this is my IT, this is my company. So hardnetservice.com. So we do a lot of stuff. We software development, right? Mobile applications, right? So a lot of things, we say our portfolio, right? And whatever the mobile development, system services, right? Networking stuff, right? Website development applications, so IT solutions, right? So apart from that, we actually, for my personal thing, we do a lot of charity work. For example, I am running this my this YouTube channel, right? A lot of charity works are there for the most of the university students, right? Especially if you want to go to YouTube, right? You can say network in Sri Lanka, right? Uh, I think, here. So this is my channel, right? This is my charity work, right? So you can see how many videos I have been. This is all free of charge. Most of the university students, they are referring. So I just want to give the brief. Not only this, I have other YouTube channels as well, right? For all things are educations, right? So what I'm trying to show, trying to tell is, my, most of the time I'm trying to give the insight of the computer technology, day-to-day life. I know how do you, so that's the my vision, my way of, testing the students. That means you should have a knowledge and hands-on of computer science. But some parents, or I because I have been teaching, more than 1,000 students, right? From whatever, in various categories, right? But some parents, they are only targeting on the exam purpose. That is fine, right? You should pass the exam. But but that is only, the subject matters only, when you read the examiner report and all. So by doing some calculation even, but they are trying to get the insight of how do you understand the concept of the computer science, right? Especially day-to-day life, if you are come across the issue in your laptop, desktop, whatever the technology you are, you have learned, you should figure it out. So for my view, my point of view, I am 100%, believe that student should have a kind of a technology expertise. Even you are learning the theory stuff, but you should apply it on that practicals, right? So that is the knowledge, that is the skill you should gain, right? So not only pass the exam, everybody can pass the exam, right? You can download the whatever the past papers, you go through it, you do it, right? It is sometimes the same thing happen. because I have been, doing many, even, yeah, pre-release material, right? The answers you can download from the internet. So even I also downloaded from the internet, I will distribute my student and I will teach how that. So exam pass is very simple thing. To get the A pass for the computer science is nothing, right? But hardest thing is to get the knowledge, subject knowledge of that particular grade, subject knowledge, what kind of a subject knowledge you have when it's come to the IT, right? I just want to tell that. So that is the thing, right? Most of the students, they just want to pass the exam, right? Passing the exam and getting the gaining the knowledge of the technology, two different things. You should remember that, right? Okay, right. Here, the memory dump is like this. Now we say I am using my laptop or desktop. Suddenly some blue stream come with some unknown text. Actually not unknown text, it's using the hexadecimal numbers, right? It says kind of error code something, right? So memory dump, that means what? Why with this memory dump? Memory has what? Memory has ICs, integrated circuits. Memory is a right. Can you hear me?
Yes, sir.
Okay. Right. Give me a second. Right. See, I got some memory dump strings, right? To elaborate. See, a problem has been detected. The Windows has been shut down or prevent damage to computer. Memory management. If this is the first time you have seen this, stop error screen, restart your computer. If this is the screen appears again, follow these steps. Click to make sure any new hardware software is properly installed. If this is a new installation, ask your hardware software manufacturer for any Windows update you might need. If problem continue, disable or remove any new installed hardware or software. Disable BIOS memory options such as caching and shadowing. If you need to use safe mode to remove the disabled component, restart your computer, right? Stop. See. මෙන්න stop bit එක. මේක මෙයා represent කරලා තියෙන මොනවලින්ද? They have represented by the hexadecimal. 0x means hexadecimal value, right? Here 0000001A, right? So this is one of the example for the Memory dump. Got it?
Yes, sir.
Right. Right. Okay, so what they are saying, hexadecimal is often used when developing the new software or when trying to trace errors in programs, right? The contents of parts of the computer memory can hold the key to help solve many problems. When the memory contents are output to the printer or monitor, it's known as memory dump, right? See, these are some messages, right? So just keep in mind, if they are asking the what is the usage of the memory dump, you can say this one: when developing new software or when trying to trace errors, right? Right, they use hexadecimal number system, right? That means they want to, they will give the error code and all using these hexadecimal numbers, right? A program developer can look at each of the hexadecimal code and determine where the error lies, right? The value on the far left shows the memory location. So these are the memory location. You know, memory location is what, you know, computer memory. If you say the memory, right? Random access memory, we have few things to clarify, right? Memory, every this random access memory has a memory address, right? Memory addresses. Memory is a storage. No, it's like our, you know, our big cupboard have small lockers. Like with memory address, we say 001, 002. These are memory addresses. Not only the memory address, we say that these are memory locations. Memory address and memory locations are same meaning. Nah? Memory address equal memory location. Memory location. Right? Here we have A, B, C, D, E, F. Right? We can put the value here. These are value of the memory. Value. Right? Value or data reside in the memory. Right? These are values. Right? So memory has a memory addresses or the memory location, right? Specific memory addresses, right? It has a space where we can put the values or data, something like, right? So if you want to read this, assuming that if you want to read this value D with this character D, you can't straight away jump. You have to go to the memory location first. It's like this. If I want to meet you, I have to first get your address. You say your home address is 50. I have to come and find this home address. We say some road. We say Maliban Street something. So when I come Melbourne Street, so number 50, I know, okay, you are located in here. So after finding the address, then I can meet you. I come and ring the bell and I ask by your name. So same thing. If you want to find, if you want to read or write in the memory, right? First of all, you have to find the memory addresses, you have to locate it, you have to find it, and you have to come. Then only you have to read it. So this is the kind of a concept of computer memory, right? Okay. So these are memory addresses. So same thing, memory locations. So that's what these same thing here. What they are mentioned, these are memory addresses. Okay. Or the locations of the memory. Clear? I think you are
Yes.
clear. Yeah, great. All right. The values of far left shows the memory location that is possible to find out exactly where is memory and fault errors. This is clearly much more manageable using the hexadecimal rather than using binary. It is more powerful for fault tracing tool but require considerable knowledge of computer architecture in order to interpret. So it's like this, right? So these are kind of a, we say computer architecture, we say CA. CA means computer architecture, right? These each and every numbers, right? Powerful tracing tool, right? Each and every code denotes some errors. For that, you have to have a computer architecture knowledge, how the memory defined, right? So something like that, right? So they say that rather than using the binary, by using the hexadecimal numbers, it's more manageable, easy to find. It is possible to find out exactly where the memory fault occurs, right? Right. Okay, so today we will wind up from this point, right? So from next week onwards, we will go with other things, and we have to discuss these things, MAC addresses, right? These are very important topics because straight away questions are coming to your exams, right?
Okay.
All right, then we will wind up the class. Okay, take care. So we'll have a class next week. Okay, Imesh?
Okay, sir.
Okay, have a good day. Thanks.
Thank you, sir. Bye, sir.
Okay,
Bye,
sir.
take care.
Bye.
Bye.